Hello everybody, welcome back to the lab. I have another interesting project here, part of the HP lot that I received a while ago. And it is a differential voltmeter, and as you can see here is also DC standard, and I will explain you why. The model is 741A and manufacturer from Hewlett-Packard, of course. And this is a very special instrument for that era, since it was able to measure voltages up to 1 kilovolt with 0.01% of error. The instrument is not functioning, it's really dirty, it's off, as all the lot, it's off since a very long time. So without further ado on this instrument, I will remove the lid, the top lid, and see how it's inside, and then we will decide how to proceed to try to bring back to life this beautiful instrument. The removal of the top lid has exposed another shield that I have already removed the screws, and ta-da! This is the internal of the instrument. Okay, clearly here somebody has already been in. I already have seen a capacitor replacement. Let me move a bit the camera. So, oh, very nasty capacitor over there. Look at that. Let me start to move the light. I hope you will see. So, for sure, and especially for the precision of this instrument, the recap will be a good thing. So let me move the camera a bit and I will be back. There are many capacitors over there, and somebody has already repaired it at some point. So for sure this instrument has seen some kind of attempt of repair. So I think that the plan of attack here will be remove all the boards and do the power supply as a first step. Well, I have replaced several capacitors so far, but the monster capacitors I've been able to reform with the Heathkit capacitor checker that I have used in the past, and I still have to check some more in this area and some in this board right here. All the other are fine, so no problem. I need to check this, and I have to replace this one that is missing here, which is right this nastiness. This is the preamplifier board, so it must be very clean signal inside this board. So I want to take care about that. So while I'm continuing to the capacitor checking, I wanna clean the front panel in order to can be used without any problem, as well as the cord here of the probe, which is very dirty and nasty, and I want to replace this very bad alligator at the end of the ground strip of the probe. Well, actually I forgot this board, which I'm recapping right now, but I found also very bad soldering blobs over the edge connector here, so I have to clean all of those. And I'm also a bit scared about this transistor replacement, since this board is the meter driver through the optic cells So hopefully I will be able to manage that. This is some of the capacitor that I have replaced so far, and the ground strip with the alligator ended up with the full replacement. Also for the wire, I found a very soft silicone wire. This is damaged in several places, so I decided at the end to replace the wire. And while I was reattaching, I have noted, it's not clear from here now, but I have noted that there is a very tiny wire, and I believe that the shield of the cable here is not well connected. So I will open the probe and see how it's inside. And my assumption seems to be correct, and indeed seems that the braid here is slide out from this crimped part here. So I need to find a way to reattach. Moreover, it's clear that this probe has been dismantled several times. There is the screw signs over there, and this should be an high precise resistor. Yeah, I believe that the AC was a problem in this instrument with this braid ground braid disconnected. So maybe there was a very bad contact problem and the instrument was unstable in the needle. Well, the more I remove things, and the worse the condition appeared to be. Here we have a very bad solder joint, and this is actually a sort of snap contact type here, but for sure that is not supposed to be like that. I laid out this from this sleeve, so I believe that I now can clean a bit the wiring here and then slide in again straight this tiny wire, check continuity and try to repair. Well, I've been able to repair the resistor tip, and so I need to keep this something here to make up focus. So I can now reassemble the probe and check the continuity. And by the way, now it fit in very precisely and tight, so really happy for the result. This is the result. So the probe is reassembled. I need to restore a bit this insulation part, and I have to machine a new probe tip, since I only have this screw at the end. But all in all, it's seems to be fine, and the continuity, it's pretty fine. So I think I can consider it repaired. Well, I have cleaned this board. I tried to remove as much as I could the solder with solder wick, and I gave also a preliminary cleaning to the board. It's not perfect, but I need to scrub the surface to clean more, but for the moment I just leave like that. I want to test the instrument, so that's okay. Let's go ahead with the replacement of the other capacitors. And by the way, I've tested the connector. I plugged the board into its connector, and clearly all the contacts are signed here, so it means that the contact clips are touching fine. So let's go ahead. Look at the last capacitor. Dead open. 450 microfarad, 50 volts. Okay, the recapping is complete, and I gave it a very quick cleaning on the front panel, on the probe wiring, in the PCB where there was signs of flux. Not very deep, but at least should be enough. Well, it's time to make some room around the instrument and plug some meter and try to power it up and see what it does. Whenever I have to power an instrument that is off from a long time like this, it is very handy, of course, to have the service manual, and I have purchased this a few weeks ago. And the first thing that I always do is to check the amount of power supplies that is producing internally the unit under test. Well, in this case, we have a very lot of amount of power supplies, since we have this unregulated, those 4 voltage regulated voltages that are duals. Then we have this high voltage supply for neon bulbs, and then we have an high precision oven reference supply. So in this case, it's not quite easy to check all the voltages all together while I'm powering up and increasing the input voltage. So what I will do is to remove this board and isolate this and check only this side, and then later, if everything is fine here, I will plug this board. So I will check the other part, and then let's see, we will see the behavior of the instrument. And just to be sure that removing the A8 board will isolate this one, I checked the schematic, and indeed removing the wall board, everything on this side will be isolated. Okay, everything is ready here. So it's a real mess, but hopefully no short circuit during the testing. So I'm going to increase the barrier, just let's say to raise up a bit. Okay, so we are already seeing some voltages, which is fine. However, I'm not seeing nothing here. That is not correct. So let me check that first. Well, fixing the connection problem, I now have the voltage reading in all the meters, but however, I still have a problem on the minus 34 voltage. I'm currently at about 90 volts, so I should see, let's say, minus 14, 15 volts, but I'm at plus 1.3. So I think there is something wrong over there, so must be investigated right now. As you can see, I'm now reading 14 AC volts, and I'm connected directly to the output of the transformer, and that relaxes me that the transformer is good. Well, actually what I've discovered is that my alligator is open, or it's an high resistance, an internal high resistance. So this is junk. Oh my goodness. Well, I will plug back the transformer and check the minus 34 rails again. And now I'm reading on the capacitor, so I'm reading DC volts, as you can see over there, and I'm now correct. So I have also increased a bit the voltage, and I'm at 120 volts around about. So it seems that it's behaving as expected. Okay, I'm at full power, and as you can see, the voltages are a little bit low. So the minus 14 and plus 14 volts are 0.3 below. Plus 25 is almost there. Minus 34 is unregulated, but it's a bit lower. And minus 28, it's minus 26. So it seems that all the voltages are a bit lower than it should. Okay, after the service manual reading and also the instrument checking, we don't have any kind of adjustments of those regulated power supply. So I decided to plug the DC standard regulation word that I have removed first, and then I will go ahead with the increase of voltage and check the output of that circuit. Okay, I in the end decided to add another meter, which is that one, that digital multimeter. So I will move the camera if we read something of interesting. However, I have set the instrument as standard, DC standard, and I will power on by this, and I will enable this, and then look at that, you are not seeing. So I will power on by this and will enable by this, and I will read the output. I should have 1 volt regulated. Well, everything is powered up, the output is enabled, but unfortunately I'm not having any output, and indeed I'm reading the minus 0.40 volt. So it's faulty, the DC standard. And yeah, I think at this point I need to prepare a different setup, but this is something that I will do in the next video. I need to clean everything and start a new setup for troubleshooting. So thank you very much for watching, and I'll be back soon with the second part.